Well, here's the Triton running. As you can see, it's got a little display of basic. So, quick tour of the machine. We've got the 5-volt regulator. Obviously on the board you've got the power system and the LED display. We'll have a little look at that again in a minute. The UART chip there, the AT80, the cassette interface stuff, main RAM and a video display, and of course it's running on my little Sony TV. So there you can, here we go, from the original side of it. What you can see on the right hand side is the debug output from the conversion for the keyboard, because we know obviously we've got to plug in ASCII, so we're using a little bit of a converter here which basically is using a Raspberry Pi interface to provide a key connection and generate ASCII codes, and so that therefore works off my standard keyboard, so that when I do a little bit of typing now, hopefully we can type run. Actually, let's have a little list first. So we've got the little program listed out, which is a program that is going to run on the Triton. So we come back now, and we should see the Triton, if you watch very carefully, when I press return, all the little lights will be counting up as it does the loop and counts it out all the way down. And these key switches here are the ones that are normally mounted on the front panel. So if I press this one, we should go back to the monitor. There we go, there's the register dump, and we've got the monitor. From the monitor we can do the usual functions like U for useful, and we're going to write to port 3, which is set to FF by default, but if I set it to 00, then over here all the lights will go on, and if I do it again and I set it to FF, they all go off. Or I can set AA, for example. So there we go. So that's working. We need a Control C to get out of that and go back to the monitor. And we can do all the features that the monitor can do, like hex dump, for example. So if we go from 000 to 0100, and there's the hex dump coming out on the Triton. So it looks like the board is fairly stable. In order to run basic, I've got Ian's memory expansion card fitted, which has one RAM chip on the left to give it an extra 8K of memory, and the Triton's level 7.2 basic on the end. Obviously the monitor's on the board. It's only got 3K of RAM chips here fitted, and the rest, which could be an onboard 8K, is left unpopulated because it's obviously on the off-board RAM. So that's it. That's a quick tour of the Triton now running. So it's now a matter of developing a proper ASCII keyboard for it, and doing something nice. Cassette interface, and the sound beeper that's added to the 7.2, and probably the serial interface. So we'll do some follow-up videos afterwards on that.